Hi, in the last session, we talked about 7 segment displays and we learned how they work and how to code them in VHDL. Now, in this session, we will do a practical on 7 segment display and clock signal. So, what we will do that we will develop a simple counter using 7 segment displays, and this will count from 0 to 9. We will write VHDL code for this and then we will implement it on FPGA as well. So let's see how we will do. First, we will write a process block for generating a 1 second signal. Basically, we are converting 50 megahertz clock signal into 1 second signal. And then we will count it from 0 to 9 for each second. And when this signal is reaches to greater than 9, then we will reset the signal to 0. And this cycle will run in an infinite loop. So our counter will start from 0 and it will count up to 9 for each second and then back to 0 again. And finally, we created a 7 segment decoder for common cathode type display so that we can see our counter on 7 segment display output. So this is the plan for this project. So let's jump to the Quarter software and start developing it on FPGA board. Okay, so we will start Quarters Prime software. So go to Start and write Quarters. So we will open this Quarters 2 10.1 web edition. We are using this version because we are working on Cyclone 2 device and that is not supported by the recent Quarters release. Okay, so that's why we are using this. But if you are working on the recent Quarters release and the recent FPGA devices, then you can use the recent releases from Quarters software. Okay, so don't worry about it. The steps are same. So first you will see this project wizard and you will see this create a new project button here. So click on this button to create a new project. So I will click on it. Okay. Now this is the new project wizard. So once you see this screen, just click on next button. Okay. Now at this page, you need to give the project directory and your project name. Okay. So for this, we will click on these 3 dots to give the project directory and locate your location. So for example, I want to create this project on this folder and I want to create it on a separate folder. So I will click on this make new folder and I will give some name to it. For example, this project is counter. Okay, so give it some name, counter, and then select it and okay. Now give the project name as well. So make it simple and I'm giving the same name, that is counter. Okay, so this is the project directory and this is the project name. And once you finish this, just click on next button again. Now, if you have any existing file which you want to use in this project, then you can add that file into this project just by clicking the 3 dots and give the file location, and Quarters will add that file in your project. But we are designing this project from the scratch. So we are not having any files to add in this case. Okay, so we will just click on next. Now this is an important page because here you will select the FPGA device on which you are working. For example, I am working on Cyclone 2 device. So I will select that Cyclone 2 from here. If you are working on some other device, then select your FPGA device. That's very important, right? And once you select your FPGA device, then all the FPGA listed with Cyclone 2 will be listed here. So you can see there is a long list here. So we need to select our FPGA from this device list. Okay, and that's huge actually. So what we will do that we will use some filters to shorten this list. How? So there's an, you can see there's a package selection. So I will select that my FPGA, it is PQFP type. So I will select it. Now pin count. So I know that my FPGA has 208 number of pins. So I will select it. Now speed grid. So my FPGA is having the 8 grid. Okay, so I will select it again. Now you can see that this FPGA list is filtered out, right? So you can see only 4 FPGA devices are listed here. So I can select my FPGA device much easier, right? So my FPGA device is this one, EP2C5Q208C8. This means I am having Cyclone 2 device, so 2C, then 5Q, that is QFP package, then 208 number of pins and speed grade is 8. So this is C8. So these are the properties of your FPGA device and that's reflected by their name as well. So once you selected your device, then just click on next button. Now, if you're doing some simulation or time analysis, then you can select the tool for the simulation purpose. For example, for simulation, there are few tools here. These are listed for the simulation purpose. So you can select any one of them which is set up in your machine. Okay. So for example, I am using this QSTA simulator. Then I can select the formats or the language. If you're working on Verilog, then select Verilog. We are working on VHDL, so I will select VHDL. But for this project, I am not doing any simulation. So it's fine if you leave these fields blank at the moment. So just simply click on next button. Now this is the summary page and it is showing whatever you have chosen from the previous steps. For example, this is your project directory. This is your project name. This is your FPGA device and this is your FPGA name, right? You have selected simulation like QSTA simulator, VSGL as a language, right? You have selected none as a timing analysis. So these all the settings are summarized here, which you have chosen in the previous step. So just review these informations and just simply click on finish. So once you click on finish, then Quartus will create the project for you. Well, this is quick. So you can see that Quartus has created the project that is named as counter. But if you notice, there is no file listed here. If you go to the file tab, then still there is no file because we have not added any file to this project yet. And even we have not created any file as well. So first what we will do that we will create a new file. So we will go to the file tab and we will click on this new button. Okay. So this is Control N from the keyboard as well. So you can simply press Control N or you can go to this file tab and click on new button. So, okay. So click on new button. Now this is a long list, but we are working on the VHDL programming language, right? So select the VHDL file. And once you select it, then click on OK. Now this is the project editor where you will write your VHDL code, right? But before that, let's save this VHDL file first. So you can see that Quartus has given some name that is vhdl1.vhd. But we want to save this file as our own way. So first what we'll do, we will save this file. So go to file tab once again and click on save as. So here this is save as button, click on it. Now locate the folder locations. So my project is inside this projects folder and then inside this counter folder, right? So I have created this counter, right? Now you can save this file inside this folder as well. But what I prefer to save all my VHDL files in a separate folder. And I name this as source. So SRC. So that is the acronym of source. That is why, because by doing this, I know that all of my VHDL files or the source file are located at the separate folder that is named as this source. So always try to use a separate folder for your VHDL files, right? So click on source and select this folder. So this is selected. Now click on save button. So this is counter and then click on save. So you can see that the title of our VHDL file is now changed. Now it is counter inside the source file. Okay. So let's write our VHDL code for this project. So first we will give library declaration. So write it library IEEE use IEEE.std_logic_1164.all. So this is our library declaration and package declaration. Now the next is entity declaration. So write it entity counter is and entity, so and counter. Now port declaration, so give it port and bracket closed semicolon. Now what we have in this project, we have one clock signal as an input. So write it clock, that is input type, and this is std_logic type semicolon. And we have 8 output LEDs for our 7 segment display, right? So suppose our output name is LED, this is output type, and we are saying this is std_logic_vector and having the range of 7 down to 0. Okay. So this is our entity declaration. We have clock as an input and we have LED as an output, but it is having 8 elements inside it. Okay. For 7 segment display. Now the next thing is the architecture declaration. So write it. So first I will write the architecture body. So write it architecture behave of counter is now begin and in the last and architecture. So and behave semicolon. So we have just written the architecture body. Now first what we will do that we will convert 50 megahertz signal into 1 second pulse, right? Because we are counting our counter from 0 to 9 at each and every second, right? and we are using 50 megahertz as in clock frequency. So that is very high. So we need to convert this 50 megahertz signal into a 1 second signal. So for that, we will use a registered process. So write a process for this. So first we will give some name to this process. Suppose I am giving process clock. Okay. So this is process and clock is in the sensitivity list because this is a registered process block. Now begin, and in the last and process semicolon. So we have just created the body for this process. Now write the structure for the register process block. So this is if rising edge of clock, then and terminate this if condition. So and if, now we will write the functioning of this. Okay. So what we are doing that we will count each and every rising edge of clock signal, which is 50 megahertz. So we will count it up to 50 million times to get 1 second. We already explained this many times in the previous project sessions, right? So I'm not repeating much in this session, but in brief, we are using 50 megahertz of clock frequency and we are converting it into a 1 second pulse or 1 second signal, right? So what we will do that we will count from 0 to up to 50 million times. So for each rising edge of this clock frequency of 50 megahertz, our counter will increase by 1 and slowly it will reach to the 50 million count, right? And once it reaches to 50 million count for this 50 megahertz clock frequency, we will get exact 1 second from it because it will take 1 second to count 50 millions for this 50 megahertz clock frequency, right? So write this counter. So what I am writing that if this counter is greater than 49,999,999, then now if you wonder that why this number that is 49,999,999, that is because we are starting our counter from digit 0, not 1. So this number is actually 1 less from 50 million. So we are starting from 0 and we'll count up to this number. And that will give us exact 50 millions increments, right? And that's what we want. So if counter is greater than this number, then what will happen? We will reset our counter to 0. So write it. Our counter should be 0, right? Else what will happen? Counter should be counter plus 1, means it will increase 1 on the last counter value. Okay, so that what this statement is doing. So our counter part is done. So we will terminate this if condition. So write and if. Now we have divided this 50 megahertz clock frequency into a 1 second cycle because we are counting it 50 million times, right? But to use this frequency divider, we need an additional signal. Like for this example, we are counting from 0 to 9 at each second, right? So we will create a signal that will count from 0 to 9. So write it. The steps are almost same like we did for this counter. So we will write that if second is greater than 9, then what will happen? That our second should be reset to 0, right? Now else if, now what we want that we want to increase this second signal at each and every second, right? And for that we are using this clock signal, right? To convert that 50 megahertz to 1 second. And we know that whenever it will complete 50 million cycles, we will get exact 1 second. Okay. So what we will write that else if counter is equals to 0, then what will happen? The second will get the value of second plus 1. So we are increasing 1 into the last second value. Okay. Now this is completed. So terminate this if condition as well. So this is and if. Now we have used this counter and second in this process block, but we have not declared it. So first what we will do that we will declare these signals in this program. So we will declare it in the architecture and begin section. Okay. So this is in between architecture and begin section. So declare it. So we have this signal that is named as counter and this is integer type and it is having the range from 0 to 50 million, right? And we have the another signal that is named as sec and that is again integer type and having the range from 0 to 9, right? Even let's do it 0 to 10. Why? Because we are using the condition that is greater than 9, right? So greater than 9 means when the second value having the value of 10, then it will reset to 0, not at 9, right? So we have given the range from 0 to 10. So our frequency divider is ready. Our 0 to 9 digit counter is ready. And now the only thing left is to drive our 7 segment display output. And how we will do this? We will use a 7 segment decoder for this. Okay, so we will write the 7 segment decoder with VHDL with select function. So write it with second select LED, which is our output, gets the value of 11111100 when 0. Next will be 0110000. This will be when 1. Next will be 11011010 when 2. Next will be 11110010 when 3. Next will be 01100110 when 4. Next will be 10110110 when 5. Let's correct it. When, okay, 5. Next will be 10111110 when 6. Next will be 111 and 00000 when 7. Next will be 11111110 when 8. Next will be 11110110 when 9. And let's all 0 when others. That will not meet actually. Okay, so because our counter will start from counting 0 and it will go up to 9. Okay, and we have defined what will be our 7 segment output for these respected values. We have already explained that from where these numbers are coming out, right? So I'm not explaining this in this session. If you want to understand this, just watch my last video. Okay, I have explained everything there, like what are 7 segment displays, what type of 7 segment displays are available in the market, what 7 segment display we are using, and how these 7 segment display works, and how to write a 7 segment decoder in a VHDL programming language. So that's what we have did in this section of code here. Okay, so we have completed our VHDL code for this project. We have divided our 50 megahertz clock frequency to a 1 second cycle. Then we used another counter to count from 0 to 9. And then this counter will drive our 7 segment decoder. Okay, so that's what we are doing in this project or in this section of VHDL code. So once you do this, just save your project. So click on save or Control S. And then the next step is compiling your project. So you can see this play button here. You can just click on it to start compilation. So just click on it and it will start compilation. So it may take little time to process it. So you can see all the information are logged here, that what is happening with your program. If your syntax is correct, if it is having any syntax error, if it is having any warnings. So you can see everything in these logs here. Okay. So you can see that I am getting this message that is full compilation is completed and I am not having any error, but there are 11 warnings. Okay. But we will ignore these warnings at the moment because we knows we have not completed few of the steps. For example, we have not completed timing analysis. We have not completed pin planner. So these all warnings are related to same. Okay, so I will click on this OK button. And if you want to see what are these warnings or errors, so you can see here. For example, this is the warning found 8 output pins without output pin load capacitance agreement, right? Next is critical warning, timing requirements are not met because we have not set the timing constraint for our project at the moment. So you can see timing requirements not met. Okay, so there are many warnings listed here, but just ignore it for the moment. Okay, so you can see this is your compilation report and you can switch to your VHDL project or your VHDL program from here as well. So these are two separate tabs here. You can just switch it between your compilation report and your VHDL source code. Okay. So we have compiled it and we don't see any syntax error in this program. So we are good to go to pin planning our design. So for this, you can see here is a button for this pin planner. So you can just click on it and open the pin planner. Alternatively, you can see it in the task section as well. So you can see, just go down little and you will see this pin planner here as well. So you can open it from here as well, or you can simply open it from this button. So just click on this pin planner button and this will be open. So this is our FPGA view. So we have selected Cyclone 2 as an FPGA device, and this is our device name, which we have selected during the initial project startup steps, right? If you remember. Now this FPGA has 4 sides. So this is side A, side B, side C, and side D. And all the side having lot of number of pins. So you can see these symbols here, these all symbols are denoted as a FPGA pin. Now, if I zoom it little, so you can see these number of pins are listed here. Okay, 11, 12. So let me take a pen tool and I little move it up. So this red point is our starting point and our counting of pin is started from here. That is 1 and it will go up to 52 for this side, then 53 for B side, go up to 104, then 105. This is side C, goes up to 156, and this is side D, 156 to 208. So if you remember, we have selected FPGA devices that is having 208 number of pins, and that is listed here as well. That is 208. Okay, so this is your FPGA view. But what we are looking for this window. So you can see that Quartus has listed all the input output ports for this project. So what we have two ports here. One is clock and second is LED. But that LED is having 8 elements inside it because this was std underscore logic underscore vector 7 down to 0. So Quartus already differentiated it here. For example, this is LED 7, this is LED 6 and goes up to LED 0. Okay. So what we will do in this pin planner, that we will tell that what pin of this project will connect to the what pin of this FPGA. Okay, for this FPGA, this is the port name and this is your FPGA pin. So we will link this port with this FPGA pin. So that what we will do in this pin planner. Okay, and for this you need to look into your FPGA board specification because that will tell you that at what FPGA pin your clock frequency is given and for what FPGA pin your 7-segment display is connected. So these all the information should be listed in your FPGA board specification. Now coming back to this table, so you can see that this is our signal name or port name. So this is clock and you can see that is input in the direction. Okay, because we have defined it. And you can see that all the LEDs are our output pins. So you can see all the LEDs are listed as an output direction. Okay, and there are few fields. These are blanks at the moment. And we are going to fill all this information here. So what we will fill, that we will tell the location of clock. So for our FPGA port, our clock is given to this pin number 23. So I will write pin underscore 23. So that's the way how you define the FPGA pin to a specific port. That is pin underscore and your pin number. Okay. Now I will give the pin numbers to the LED output. That is our 7-segment display output. So for my FPGA board, it is connected to pin number 34. LED 6 is connected to pin number 35. So give it 35. Next is connected to 39. So give it 39. Then LED 4 is connected to 44. So give it 44. LED 3 is connected to 43. So give it 43. Next is connected to 37. So give it 37. Next is connected to 40. So pin number 40. And the last LED is connected to 41. Okay. So I will give it 41. So I have listed all the input output pins for my project. Now, if you click on any of the signals or any of the port here, for example, I have selected this clock signal. And if you go to this FPGA view, so you can see that this FPGA pin will be highlighted as in blue border. So that means this particular pin is selected from the FPGA and that is connected to this clock port. Same way, if you select this LED 7, so you can see that this is connected to pin number 34 of this FPGA. Okay, LED 6 that is connected to pin number 35. LED 5 that is connected to pin number 39. LED 4 that is connected to pin number 44. LED 3 that is connected to 43. LED 2 that is connected to 37. LED 1 that is connected to 40. LED 0 that is connected to 41. So we have specified all of these input output ports with this FPGA pin or this FPGA board. Okay. Now, important thing is that you do not need to save anything after making all these changes because pin planner automatically save all this information for you by default. So whenever you make any changes in this list, this pin planner will automatically save. So you will notice that there is no save button in this window here. Okay. Because this is automatically gets saved when you are making any changes in this view. Okay. Now there is one important thing to tell you about FPGA. So all these FPGAs are having some number of banks inside it. For example, this FPGA has total 8 number of banks and each FPGA pin belongs to some specific input output bank. So you can see that all of these input output ports which we have defined in this project, these are connected to these FPGA pins, and these all FPGA pins are belong to this input output bank. Now important thing is that these all input output banks having their own power supply, means these all IO banks have their separate power pin. Okay, so if you specify the location of your input output ports, it will automatically fill your input output bank. Like here we have just filled the location and input output bank has automatically filled. Same as with the V reference group as well, because this FPGA has a predefined set of standards for input output. For example, you can see that input output standard is by default set to 3.3 volt LVTTL, and you cannot change this for this FPGA. But the modern FPGAs are more flexible, where you can select these input output standards as well based on your FPGA board manufacturer. So you will get more control. But for this FPGA, this is very straight because we do not need to change anything in this specification. Okay, so we have specified all the FPGA pins for all our input output ports. Now once you completed it, just click on this close button because it is already saved. Now one more thing, that you do not need to go again and again to this pin planner until you are adding any new port into your entity or into your project. Okay, so for this project, you just define it once and then forget it, and it will remain same for all the changes which you are making in this program. Okay, so we have defined the input output ports and we tell the quarters that what ports are connected to what FPGA pins, right? Now after doing this, you need to recompile your design. So again, go to this play button here and click on this start compilation button. So click on it. Now again, it will compile your program and will give you the results. So you can see that the full compilation was successful and there is 10 warnings still because we have still not completed the timing constraint part, but we will ignore it. Okay, so just click on OK. Now this is the time when you program your VHDL designs into your FPGA board. So what we will do, that we will open the programmer. So you can see this button here. So this is for programmer. You can open this programmer from this button, or still you can go to this task section and you will see this programmer device or open programmer here as well. So you can open it from here or you can open it from here as well. So just click on this programmer. Now click on OK. So this is your programmer. Okay, let me wide this little so that you can see all the information listed here. Okay, so this is our counter.sof. So this is our binary file which will be implemented into our FPGA. Okay, and this is our device name, that is EP2C5Q208. This is checksum for some validation of this binary file, user code FF, that is none, and make sure that your program and configure button is ticked. This is your progress bar. So once you start flashing your FPGA device, you will see the progress here. Okay, and now this is your hardware setup. Then you can see that USB blaster USB 0. This is listed here for my device. Okay, if you do not see anything here, then just click on this hardware setup button and you should see this programmer device listed here. If you're not seeing this here, that means your programmer is not connected with your PC, or maybe there can be a driver issue. So in that case, just update your driver and reinsert your USB device or programmer device. Okay, and once you see this device listed here, just select it and click on close, and then you will see that your device should be listed here. Okay, so once you see it here, so select your binary file and then you will see this start button flashing here. Okay, so just click on this start button and you can see the progress here. So that is quick, 100% successful. And now we will move to our FPGA board to see that what we are getting at the output of our 7-segment display. We are expecting that our 7-segment display should count starting from 0 and it will go up to 9, and it will count at each and every second. Okay, so it will start from 0, then count 1, then 2, then 3, and it will go up to 9 at each second. So let's move to the FPGA board and see if we are getting the right results or not. So this is our FPGA board and this is our 7-segment display. So you can see our counter starts 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Okay, and you can see that is happening continuously in a loop. So that means our FPGA design is working well and our VHDL code is perfectly fine and it is doing the right job for what we have designed it, right? Okay, so that was our demo for this project. Hope you liked it and learned from it. So you see that first we converted 50 megahertz clock into 1 second signal. And then we counted it for each second from 0 to 9. And once its value greater than 9, we reset it to 0 and counting starts again. Just a note, because I'm using Cyclone to device, so I have used this quarters old version, but steps are almost same for designing and implementation on quarters. In the future session, we will be covering more such projects and we will be implementing them on FPGA board as well. We will see different real life issues like bouncing of switches, etc. In the future session, we will be covering more such projects and we will implement them on FPGA board as well. We will see different real life issues like bouncing of switches, etc. And we will learn how to solve them. So stay tuned for the update. If you did not subscribe till now, then please do subscribe to learn and grow community for regular updates. If this video is informative, then please like this video, comment on video, and don't forget to share. Thank you for watching.